Hey everyone, this is example number 14 from R S Aggarwal, page 341. So this is the question. Fx is sin a plus 1x plus sin x by x when x is less than 0. It is c when x is equal to 0. It is x plus bx square root minus root x by b h power 3 by 2 x more than 0. So they are saying you have to find a, b, c. It is giving that function is continuous at x is equal to 0. So if it is continuous, then LHL, if it is function is continuous, then what should happen? LHL is equal to RHL should be equal to function value. These three should be same. We will calculate one by one. LHL. First of all, for LHL, it is limit x tending to 0 minus, correct, less than 0, f of x. So less than 0, which one we will take? We will take this one, less than 0. So it will be sine of, let me write it, a plus 1 sine of a plus 1x plus sine of x by x. This is the question. Since there is a numerator and denominator, we can use H method, or we know one formula that limit x is tending to 0, sine of x by x is 1. So we will try to use this formula. Okay. So to solve it, first let me apply H method. So how to solve it? By using H method. So we will replace x by 0 minus h and limit will go to 0. That's how we will do. So it is limit x is tending to 0 minus, okay, sine of a plus 1 0 minus h plus sine of 0 minus h. See here, this x and this x I am replacing by 0 minus h and 0 minus h by 0 minus h, correct? And limit is tending to h, limit is tending to 0, correct? So that is how we solve. Limit changes from here to here and x is replaced by 0 minus x everywhere, okay? So there was some problem. Let me write down here. So it will be limit h is tending to 0, sine of a plus 1 0 minus h will be minus h, correct? 0 minus h will be minus h. So this minus I am writing here plus sine of minus h by minus h. We know one thing, sine of minus theta is plus of sine theta. We know that. This minus comes in, this minus comes in front. This becomes minus. This minus comes in front. So what I will do here is, see, limit h is tending to 0. This minus will come in front. So it will become sine of a plus 1h. And this minus will come in front, minus of sine h by minus of h, okay? So now can I take this minus common here, upper? If this is minus common, this will become plus, correct? This will become plus. So now this minus and this minus will become plus, okay? Now we can split it. Sine of a plus 1h by h plus, we can split it, correct? And this by this. So it will be sine h by h. So whenever we have this, the limit goes to both this also and this also. limit will go to both. So let me solve it. Limit h is tending to 0, sine of a plus 1h by h, plus this will be limit, h is going to 0, sine of h by h. Yes, this is what we got. Now in this part we can apply formula. Sin h by h will be 1 because h is tending to 0. Correct? What can we do here? Here we should notice one thing, that with h there is a coefficient. So we know this formula, that sin of x by x limit x is tending to 0 is 1. This is a formula. Okay? Write down this formula. This formula is valid for any value if these two are matching. This x by x is matching. If it is 2x by 2x, then also 1. 3x by 3x, then also 1. If these two are matching, then we can use this formula. Here this is a plus 1h, here is only h. So how can we make it matching? Can I multiply a plus 1 purposely down and a plus 1 up? We can multiply. Now in this part, these two are matching. This and these are matching. So this will become 1. We can apply formula. And a plus 1 will remain as it is. Correct? When we apply the limit h tending to 0, let me show you. A plus 1 will come in front. A plus 1 will come in front. So limit, this will become, let me write down. A plus 1 will come in front. Limit h tending to 0, sine a plus 1h by a plus 1h plus, this is 1 only, this part is all 1. So this will be a plus 1 into, what is this part? We can apply this formula because this is applied when these two are matching. When these two are matching, so this will be 1 plus 1. So total answer is how much? If we simplify it, a plus 1 is a plus 2. So this is my left hand limit. Okay. So this was the question. You can solve it again. This was the question and we got left hand limit as, let me just write down here, and then we will do RHL. So left hand limit we got a plus 2. Now we will solve it for RHL. So for RHL is more than 0. For more than 0, we will select this one for more than 0. Correct? So if we select this, what will be the value? Let's solve it. For RHL, limit RHL, limit x is tending to 0 plus fx. So what was the value of fx for tending to 0 plus? From the question, if we write down, it was root of x plus bx square minus root of x by bx power 3 by 2. Correct? Because this function was true for x is more than 0. To solve such problems, wherever there is an under root involved, okay, wherever under root involved, let's try to multiply up and down with opposite sign, which is known as rationalization. So what, this is with minus sign, I will multiply same thing with plus sign up and down. Let's see. This is bx square plus root x divided by root of x plus bx square plus root of x. Correct? Okay, now let's see what can we do. So this is a minus b and a plus b. Correct? This is a minus b, a plus b. So what is the formula of a minus b and a plus b? Formula is a square minus b square. This is the formula, right? A square minus b square. So this will be limit extending to 0 plus a square minus b square will be what? This under root will disappear. This is square minus this square is x plus bx square minus of x. Correct? Root a minus root b. Root a plus root b is a minus b. See here, root a minus root b. Root a plus root b is a minus b. I think everyone knows by now. Divided by whatever it is, b x की power 3 by 2. Let me write down here, under root of, here we will do one more manipulation. Can I take x common in these two? So it will be 1 plus bx plus root of x. Okay. Now what can we do to simplify? Now what we are getting is x and x is cancelling. Correct? And then this b and this b is cancelling. So what we are getting, just keep on solving patiently. X square by x power 3 by 2. In these two, can we take root x common? Here. In these two, can we take root x common? Just patiently keep on solving. You will reach there. Root of x common. So what is left here is root 1 plus bx plus root of x. Okay? Simplify further. What is 3 by 2 into root x? What is this? This into this. Let me see here. X power 3 by 2 into root x. So root x is power half. So it will be 3 by 2 plus half. Powers are added. So it will be, since powers are added, so it will be 4 by 2, which is x square. Correct? So this is nothing, this part which I solved here is nothing but x square. Right? You can pause it and try on your own. So this whole part I got is x square. Let me write it here. Now what it looks like. What it looks like. I think this will cancel. This x square will cancel. So what we will get is limit x is tending to 0 plus 1 by root of 1 plus bx plus root of x. Perfect. Now it's in algebraic expression. Let me just try to put x is equal to 0, whether we will get answer or not. Let's see. So x is equal to 0, 1 by, what I am getting is root of 1 plus 0, because x is 0, this part, and this is 0. Correct? So this is plus root of, I am sorry, I did a mistake here. When we took root x common, guys, here I did a little bit mistake, please check it out. When I took root x common here, so this root x will become 1. Please make a correction. This root x would have become 1. Be careful here. Be careful. Let me write down. Be careful here. When I took this root x common here, so this would have become 1. So let's continue. This was root of 1. Root of, I'm sorry, just root x came out, so it is 1 only. So this is 1 only. So here I will get plus 1. Okay, plus 1. So what I will get is 1 by 1 plus 1, which is 1 by 2. So here it is root of 1, which is 1 only, and 1 plus 1 is 1 by 2. So this is my second answer, which I am getting RHL. Okay, this was my RHL. Okay. Now if you look at the question, we have to calculate f of 0, function value at 0. So function value at 0, what is given? Function value at 0 is already given, which is f of 0, and f of 0 is given is, I think it was given as C. So we got three values, RHL, LHL and function value. RHL 1 by 2, LHL was A plus 2, and 0 is C. So we are supposed to calculate the values of A, B and C. So if it is a continuous function, so LHL is equal to RHL is equal to this, all three. So LHL is A plus 2, RHL is half, and this is C. Right? So from here we can make an equation. Equation will be A plus 2 is half and C is half. So from here A will be how much? Minus 3 by 2. And we can see that it does not matter what is B value, because B is not even appearing in RHL or LHL or F0. So B can be any value because it is not affecting our, B can be any value because it is not affecting LHL or RHL or function value, or it is not hindering in a function to be continuous. So this is our final answer, A, B and C. Next problem. This is example 15. Fx is defined as this. If it is continuous at 1, find AB. Okay, before looking at the solution, try on your own. So I hope you have tried. So let's do LHL. LHL is left hand side, so which is written as limit x is tending to 1, because here it is continuous at 1. So I will write 1 minus f of x. So which one we will take? Less than 1 is this one. Okay, so let me take this one only here, which is 5ax minus 2b. Okay, now because it is just a plain algebraic function, there is no need of h method. I can just put x is equal to 1. So I will get 5a minus 2b, which is 5a minus b. This is LHL. Okay, so this is my LHL over. Let me write down RHL. So for RHL, limit x is tending to 1 plus means more than 1. So which one should I take? This one? Yes or no? This one, more than 1. So I will take 3ax plus b. So here directly I can put x is equal to 1. No need of taking h method. Correct? Here. So 3a into 1 plus b, which is 3a plus b. This is RHL. And now what is the function value? Function value is given this at x is equal to 1, which is 11. It is given. So guys, I got LHL, I got RHL, and I got function value. From here we will calculate A, B and C. Let's write down what we got. 5a minus b LHL is equal to RHL is equal to 11. This is what? For continuity, all three should be equal. Out of this, if this is equal to this and this is equal to this, we get two equations. and 2 unknowns. So let me write down 5a minus b is 11 and 3a plus b is 11. These two equations. So now we are supposed to just solve it. So here, in order to solve it, here just let me see, this was 2b. So this will be, guys, 2b here. This is 2b, 5 minus 2b. So 5 minus 2b is 11. Okay, this one. And second one is 3a plus b is also 11. These two equations, 5a minus 2b is 11 and 3a plus b is 11. How to solve these two equations to get a and b? I think you know already. So I am writing answer. A is equal to 3 and b is equal to 2. Next question. So here is the example number 16 from R S Aggarwal. You will find on page number 343 or maybe different page according to your version. Now let's see. They are saying the function is continuous at 0 and x is equal to 1 and x is equal to minus 1. So you have to find k value for all three cases. So let me take case 1 where x is equal to 0 per it is continuous at x is equal to 0, 1 point, correct? For this we will calculate LHL, RHL and the function value, all three, okay, for this value. So let me do it here. Let me calculate RHL, then here I will do LHL and here I will do the function value at 0. So for RHL, limit x is tending to 0 plus. 0 plus means this one we will take, by now you know. Take it. 0 plus means this one we will take. So it will be 4x plus 1. Now just put value 0 here because it is just a polynomial, so we can put 0. So 4 into 0 plus 1 is 1. This is RHL. LHL में देखिए, limit x is tending to 0 minus. So when we put 0 minus, so I have to take this one, which is k for LHL, k x square minus 2x. So that just put the value 0. So k times 0 minus 0, which is 0. This is LHL. And what is the function value? At 0 itself. So at 0 means the equal 0. This one I have to take when it is equal to 0. So what I will get is, let me write down. Function value at 0 will be this one. I will take less than 0, k times 0, which is 0. In this you can see that RHL is 1. But LHL is 0, function value 0. So I can say LHL and RHL are not even equal. Okay. So that means function is not even continuous for any value of k. Okay. So we can write down function is not continuous for any value of k, means it does not matter what is k, the function will remain discontinuous, correct? Because it does not depend on the value of k. Now let's check for 1. Okay, now we are checking for x is equal to 1. So I will do RHL, then LHL and then function value, and then we will decide what is the value of k. So for RHL it will be limit x is tending to, for RHL 1 plus, because we have to check at 1, so it will be 1 plus, little bit more than 1. So where it is little bit more than 1? Less than 0 or more than 0? Which one should I take? More than 0? More than 0 is 1 or 1 plus 1? See, 1 plus means little bit more than 1. So I am supposed to take this only. Okay? Because 1 is more than 0. So it is 4x plus 1. Now put the value x is equal to 1. Put it. So this will be 4 plus 1 will be 5. This is my RHL value. Now LHL, limit x is tending to 1 minus. X is tending to 1 minus. So 1 minus means it's very close to 1 but not 1. Very close to 1. Little bit less than 1. Means x is approximately maybe 0.999999. Means very close to 1 but less than 1. Okay. So which one should I take? In this or this? 0.999 is still more than 0. So I should take this because it is not less than 0. 0.999 x value. Okay. So 1 minus, for 1 minus we should take this one because it is still more than 0. So it is 4x plus 1. Now you put 1, 4 into 1 plus 1, which is again 5. Now we will take f1, the functional value at 1. So which one should I take? This says more than 0 and this says, this one says less than 0 and this one is more than 0. What does it mean? More than 0. This one we will take because we need f1. So it is 4x plus 1. Put x is equal to 1, which is 5. So here we are getting LHL, RHL function value. You can see RHL is also 5. LHL is also 5. Function value is also 5. Means no matter what is the value of k, it's always continuous. For any value of k, function is continuous. Okay. So what we can write here, fx is continuous for any value of k. So its continuity does not depend on k. This is the conclusion. Okay. Now we will do for next case, which is x is equal to minus 1. Okay, let's try it. So now we are doing at x is equal to minus 1, the limit checking. Okay, so for RHL and LHL we will calculate. So limit x is tending to minus 1. RHL, for RHL we will take little bit more than minus 1. Little bit more than minus 1 but not minus 1. So more than minus 1 it will maybe minus of 0.9999. Correct? More than minus 1 is this. Okay. So which one should I take? This or this? Minus 0.999. It is still less than 0. Okay. Minus of 1 positive. Matlab a little bit less than, a little bit more than minus 1, which is this possibility. Correct? If you check on number line, you will see it has to be this, which is still less than 0. So which one should I take? Which is still less than 0? This one. Correct? So let me write down k x square minus 2x. So let me put x is equal to 1 here. So what we will get? So let's put x is equal to minus 1, not 1, because we have to check the limit at minus 1. So k of minus 1 square, 2 of minus 1. So which is k 1, and minus will become plus of 2. See here, minus 1 square became 1 and minus of minus became plus. So it is actually 3k. So this is my RHL. Now LHL देखते हैं. Limit x is tending to minus 1 minus f of x. So it is minus 1, little bit less than that. So little bit less than, more less than will be minus of 1.00001. Okay, more left side. Less than this means more left side. So it is this one. It is still less than 0. It's still a negative number which is less than 0. So for definition, we should pick up again this value. Correct? This one. We should pick up this value again. So let me write k of x square minus 2x. Now let's simplify it. For simplifying, we will put x is equal to minus 1. Remember, we will put x is equal to minus 1, not 1. Okay. So k minus 1 square minus of 2 into minus 1, which is k 1 plus this minus and minus will become plus, which is 2k. I am sorry, this is plus 2. This is plus 2 and it will become 3k. Now what is f of 1? Function value at 1. 1 is more than 0. I will have to take again this one. So which is k into x square. We are checking on minus. I'm sorry. We are checking on minus 1. F of minus 1. Correct? So minus of 2x. Minus is less than, minus of 1 is less than 0. I am picking up this value. So k of minus 1 square minus of 2 into minus 1. So which is k into 1 of 2, which is again 3k. So what is the observation here? The observation says that no matter what is the value of k, we are getting RHL is also 3k, LHL is also 3k, and function value is also 3k. For all values of k, it will be continuous because we are getting LHL. For any value we are getting LHL is equal to RHL is equal to function value minus 1, correct? So it is continuous for any value of k, no matter what, because we are getting 3k for all left hand limit, right hand limit, and function value. Next question. This is example 17, which is very important. So they have given fx is given. This is the function. Please write down. This is the definition of the function which is given. When x is not equal to 0, it is this. When x is 0, it is 1. So they are saying it is discontinuous at 0. They are saying it is discontinuous. I'm sorry. It is discontinuous at 0. X is equal to 0. You have to prove it first. And then you have to redefine it in such a way that it is continuous at x is equal to 0. So how to define it? First we need to prove it is discontinuous. So let me calculate LHL. Okay, LHL or RHL. So we can do RHL also. It's fine. Any one thing is fine. So let me do RHL. To limit x is tending to 0 plus, because we need to test the continuity at 0, 0 plus. More than 0. So more than 0 means we will take this one. So it is sin square ax by x square. Correct. To find the limit, I am thinking if I can use this sin x by x is 1. If I can use. But the condition for this is that this x and this x should match. Here this is ax and this is only x. Correct? Let me rewrite it. This is nothing but limit x is tending to 0 plus. So I can write sin ax by x whole square. We can write, correct? So here it is ax. If we observe, here it is ax and here is x. They are not equal. We cannot apply this formula. This formula is applicable when this x and this x is matching. If it is 2x, 2x, 3x, this is 3x, or kx, this is kx, then it is 1. But it's not a big deal. We can match it. How? You can see here. Can I multiply by a here purposely and a here? Now it is matching. So now question will become this plus. This is a square. I am taking out of it. So it is sin ax by ax square, because this one is coming out of bracket, a square. This part now we can apply the formula, which is 1, right? The limit limit x is tending to 0 to, is 1, so that means its right hand limit or its left hand limit is also 1, correct, because the value is 1. So it will be a square into 1 square if I am putting formula here, which is a square. So its right hand limit of the question is a square. Okay, now if you check the function value, what is the function value at 0? So right hand limit we got is this. Let me calculate the function value. Let me write down f of 0. F of 0 is 1. And what we got RHL is a square. These two are not equal. These two are not equal. So that means we proved that it is discontinuous. How to make it continuous? To make it continuous, we should make the limit value and the function value equal. To make it continuous, the limit value and the function value should be continuous. Should be equal. Right? So how can we redefine it? See here. If I redefine it in such a way that f of x is sine square ax by x square let me know it, is when x is not equal to 0, but we define it a square when x is equal to 1. So functional value will also become a square and limit value we were getting a square. So now this function will be continuous because for this RHL will be equal to LHL will be equal to function value. This was at 0. Correct? So this is how we can redefine for making it to be continuous. Let's do next question. This is example 18, which you will find on page number 344, the old version of R S Aggarwal. So this is the question, fx is 3x plus 4 10x by x. So they are saying, is it continuous at x is equal to 0? So you have to find the continuity. If it is not continuous, then how to make it continuous? If not, then how to make it continuous? This is the question. So guys, for continuity, we need 3 things: RHL, LHL and the function value. These 3 should be equal. So when any function is given, the first thing, especially when it is a fractional function, means it has numerator and denominator both, the first thing we have to check is function should have the value. At least at that point it should have a value. F0 should be at least defined. If F0 is defined, then we can calculate RHL and LHL. This is true for something which is a rational number, numerator and denominator. So let's find F0. So F0 is 3 into 0 plus 4 tan 0 by 0. Correct? How to find F0? I am putting x is equal to 0. That's it. So I am getting 0 plus 0 by 0. 0 by 0. 0 by 0 in maths is completely undefined. 0 by 0 is not an accepted value in mathematics. That means function value itself does not exist at 0. So there is no use of finding RHL and LHL. Correct? So this is function is discontinuous, definitely. Understood? So how to make it continuous? So first of all, we should define it at 0. So we should give a new definition to the function. How? In such a way that it is at least defined. It has some value at F0 and that value should match with the limit value, LHL value or RHL value, right? So let's calculate RHL value, how much it is. Let me calculate RHL. So how to calculate LHL? Limit x is tending to 0 plus 3x plus 4 of tan x by x, or we can just calculate the limit value directly. Okay, so let me see, it will be limit x is tending to 0 plus, can I write 3x by x and this by this and this by this, we can split it, 4 tan x by x. Okay, so we will get limit x is tending to 0 plus 3 plus 4 tan x by x. Why? Because this x, you can see here, this x and this x will cancel, so it is 3 plus 4 tan. Next by x. Now what will be the value of this limit? Let's calculate. There is a formula, write down limit x is tending to 0, tan x by x is 1. This is a formula. Limit value of tan x by x is 1. Limit value is 1 means its RHL, its LHL, both will be 1. Okay, middle is 0 plus value and 0 minus, both will be 1 only. Correct? So if I am finding limit, so it will be 3. See, this limit will go to this also and to this also. Here there is nothing to calculate. This is 3 only. So I am writing 3. Limit x is tending to 0 plus 4 tan x by x. And what is tan x by x value at 0? Is 1 only by this formula? Is 1? Yes. So it will be 3 plus 4 into 1, which is 7. So my limit value of this function is coming to be 7. But the function value, it was not even defined as we calculated before. Correct? So this is the problem we are facing in this. LHL is there, RHL is there, but function is not defined at x is equal to 0. So we can give a new definition to the function, redefine. How can we redefine it? Can I write fx is, let me write 3x plus 4 tan x by x when x is not equal to 0, but it is equal to 7 when x is equal to 0. Okay? Now I am matching the function value when x is 0 equal to 7, which is my limit value of the function. So in this case, whenever I will calculate the limit value, that will also come 7 from here. Left hand limit, right hand limit will also come 7, and function value will also come 7, because I have redefined it. I have defined that function has a value 7 when x is equal to 0. So please try to solve it once again. Let's do one more question. Guys, next question is a little bit longer, which deserves a separate video. So I will do in a separate video. Bye for now.